morning students. Today is lecture 4 of chapter 1. Yesterday we discussed Coulomb's law and we know that suppose there are two charges, point charges q1 and q2, and they are separated by a distance r in vacuum, then the force of interaction between them, it will be directly proportional to the product of the charges. That means F is directly proportional to q1 into q2, and the force will be inversely proportional to the square of the distance between them. So we know Coulomb's law is F equal to k q1 q2 upon r square, where k is electrostatic force constant and the value of k is 9 into 10 to the power 9 Newton meter square per Coulomb square. This value of k is for free space, that means for vacuum or air, and this can also be written as 1 upon 4 pi epsilon naught. So when you will put this value in this equation, you will get F equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. This is the Coulomb's law which we will be using. Now here epsilon naught is the absolute electrical permittivity of free space, that means vacuum, and its value is 8.85 into 10 to the power minus 12 Coulomb square per Newton. So today we will discuss dielectric constant, which is denoted by capital K. Suppose there are charges and they are situated in a medium other than free space, then the force between them, it will be given by 1 upon 4 pi epsilon q1 q2 upon r square. This will be the force between these two charges q1 and q2 separated by a distance r in a medium other than free space. Here m denotes for medium. Now here we have used quantity epsilon. Epsilon is the absolute electrical permittivity of the intervening medium, that means the medium which is present between q1 and q2. It can be water, it can be oil, it can be any other medium. Now suppose these two charges are held the same distance apart in vacuum, then the force between them, it will be F naught equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. Now because these two charges are in vacuum, so we have used epsilon naught. Now divide this equation 2 by equation 1, you will get F naught upon Fm equal to epsilon upon epsilon naught, because other quantities like q1 q2 upon r square, they will get cancelled. So this ratio epsilon upon epsilon naught, this is denoted by epsilon r or k, and epsilon r here is relative electrical permittivity of the medium and k is the dielectric constant of the medium. So this is how we define dielectric constant or relative electrical permittivity of the medium. Both are same thing, we have written equal to here. Now for vacuum, remember for vacuum or for air, k is always taken as 1, whereas for other mediums k will be different. For water k will be 81, for some other medium k will have some other value. Now next we have to discuss principle of superposition. According to this principle, total force on any charge due to a number of other charges at rest is the vector sum of all the forces on that charge due to the other charges. Now let us try to understand this principle of superposition with the help of this diagram. Suppose there are four charges. One is q naught, other charges are q1, q2, q3, and these charges are in free space. Now q1 will exert force on q naught, which we have denoted by F1 vector. q2 will exert force on q naught, which we have denoted by F2 vector. Similarly, q3 is exerting force on q naught, which we have denoted by F3 vector. So all these three charged particles q1, q2, q3, they are exerting force on q naught. Now the total force on q naught, it will be the vector sum of these three forces. So according to superposition principle, total force on q naught, it will be the sum of F1 vector plus F2 vector plus F3 vector. So this is the total force on q naught, which is the vector sum of all these three forces. So this is simply principle of superposition.